Today we're going to talk about functions. A function is a rule that assigns each element of one set to exactly one element of another set. The first set is the domain, the second set is the range. This is an example of a function. The first set on the left is the domain, and each element in that set goes to exactly one element in the second set, which is on the right. So the right side is the range. This is another function. The first set, the domain on the left, goes to exactly one element of the range on the right. Now notice that the little star and the happy face both go to the same element, the donut. That's okay. As long as they just go to one thing, they can go to the same thing. This is not a function because the star goes to two different places right here. So this element makes the whole thing not a function. Does this table describe a function? If you look at the x values or the domain, notice that every single x value is different. So every x value has its own unique y value. That means that this is a function. In this table, the value of 1 has a y value of -2. But this x value of 1 has a y value of +2. This is not a function because we have a value of x that has two different values of y. Here's another one. If x is 0, y could be -4, could also be +4. So one value of x has two different values for y. That means this is not a function. In each equation, is y a function of x? I would recommend that when you answer these questions, you solve for y to start with. So we're going to take the square root of y on both sides, or the square root of both sides rather. And so y is equal to plus or minus the square root of x. If we were to graph this, it would look something like this. If x is 0, then y is just 0. If x is 1, y could be 1, but it could also be -1. If x is 4, y could be 2, but it could also be -2. So this is not a function. It actually looks like a parabola turned on its side, but you'll notice that each x coordinate has two possible values for y. So that makes it no longer a function. For part B, question B, let's solve for y. 1 minus x squared. If we graph this, it's actually going to be a parabola that is opening down. It'll look kind of like that. So for example, if x is 0, then y is 1. If x is 1, then y is 0. If x is -1, y is also 0. You can see every value of x has exactly one value of y. So this one is a function. Part C. Let's solve this for y and see what happens. 1/8 y is going to equal -x cubed plus 2/3. And then let's multiply everything by 8. So y equals -8x cubed plus 16/3. Here's a picture of the graph of the equation that we just found. And you can see from this graph that every x-coordinate has exactly one y-coordinate. What we're really using here is something called the vertical line test. And that says if you can draw a vertical line, which sometimes is a challenge for me to draw a vertical line. Let's try again. If you can draw a vertical line through the graph and have the line only go through it one time, I'm having trouble with this vertical line thing. If your vertical line only goes through the graph once, then you have a function. Try one more time. That's a little bit better. Any place I draw a straight vertical line, it's only going to go through the graph once. So yes, this is a function. Okay, now we have some notation. This notation where it says y equals f parenthesis x parenthesis, we read that y equals f of x. F is the name of the function, y is the dependent variable, x is the independent variable. F of x is the value of the function at x. Domain, just like before, is your x values, and range will always be the y values. Evaluate the function at the specified values of the independent variable and simplify. This means that whatever is in the parentheses will be substituted for x. So f of -8 will equal the square root of -8 plus 8 plus 2. So that's the square root of 0 plus 2, which is just 2. F of 1 would be the square root of 1 plus 8 plus 2. The square root of 9 plus 2 is 3 plus 2, which is 5. F of x plus 8 means that we're going to substitute x minus 8. We're going to replace the x with x minus 8. Then you still have the plus 8 under the radical, and then we have the plus 2 on the outside. So that's going to end up to be radical x underneath, and then a plus 2 on the outside. So all of the x minus 8, everything in the parentheses, replaces the x in the function. This is a piecewise defined function. That means that you only use the x squared plus 2 when you have a value of x that is less than or equal to 1. You only use the 2x squared plus 2 when you have a value of x that is greater than 1. So for part A, f of -2, we will use the first equation because -2 is smaller than 1. So we're going to write -2 squared plus 2. That's going to give us 4 plus 2, and that equals 6. For f of 1, we again use the first equation because 1 is equal to 1. So 1 squared plus 2 is going to be 1 plus 2, and that's equal to 3. And then finally, f of 2 is bigger than 1, so we use the second equation, 2 times 2 squared plus 2. 2 times 4 plus 2, 8 plus 2 gives us 10. For this example, we want to know when the functions are equal to each other. So we'll just do exactly that and say x squared plus 2x plus 1 equals 3x plus 3. Subtract 3x from both sides. Subtract 3 from both sides. X squared minus 1x minus 2 equals 0. and we're solving this function. So let's go ahead and factor that. You could also use quadratic formula if you would like. X minus 2 equals 0, so x equals 2. X plus 1 equals 0, so x equals negative 1. Those are our two answers. Those two values of x make the functions equal to each other. We have talked about domain before. The only restrictions we have on domains are when we have radicals and fractions. This example does not have a radical or a fraction, so the domain is all real numbers. In interval notation, you could write that negative infinity to infinity. Example B is a fraction, and we know that we cannot have denominators of 0. So to find the domain, you'll say that y plus 5 cannot equal 0. Subtract 5 from both sides, and y cannot equal negative 5. And that is your domain. With radicals, the radicand, the number underneath the radical, has to be greater than or equal to 0. So the domain for this problem is x is greater than or equal to negative 2. This is a difference quotient problem. And you need to think of this really as sort of three separate problems. We're going to find f of 5 plus h, then we're going to find f of 5, we'll subtract those, and then divide everything by h. F of 5 plus h means that we take the 5 plus h and put it in for x into the function. So it's going to look like this. F of 5 plus h equals 5 times 5 plus h minus 5 plus h quantity squared. Let's distribute the 5. 25 plus 5h minus, hang on to those parentheses, we need to FOIL this, 25 plus 10h plus h squared. Now distribute the negative. 25 plus 5h minus 25 minus 10h minus h squared. Combine like terms. 25 minus 25 is 0. 5h minus 10h is negative 5h minus h squared. So that's our f of 5 plus h. We're going to hang on to that. Now we're going to do f of 5. F of 5 is this part right here. That will be 5 times 5. Again, I'm putting the number that's in the parentheses in for the x. Minus 5 squared. 25 minus 25 is 0. So now we can rewrite the problem. F of 5 plus h we know is negative 5h minus h squared. And then we have a minus right there. F of 5 is the 0. The whole thing is over h. We end up with negative 5h minus h squared in the numerator. We don't really need this 0 here. And there's an h that we can factor out. That leaves us with negative 5 minus h over h. Then the h's cross out, and the final answer is negative 5 minus h. Please bring these notes with you to class tomorrow, and we will do the word problems together.